We have a circle, and inside the circle, we draw two line segments, such that they are perpendicular to each other. Also notice that one of the line segment passes through the center of the circle. Our task is to find the radius of this circle. There are many methods to solve this problem, but we'll use one of the easiest methods. That is, the Chords intersection theorem. The chord intersecting theorem states that if two chords intersect inside a circle, the products of the lengths of the segments of each chord are equal. To apply this theorem, we extend these two line segments until they become chords of the circle. After extending, let's label all the points. Now, start from here. Let's label this point as point A, the point where the line intersect as point B. Point C is on the circle on the right side. The center of the circle as point O. Point D is on the circle at the top. Point E is on the circle at the bottom. Now we have two chords, chord AC and chord DE. Notice that the chord AC passed through the center O. This chord is actually a diameter of the circle. Now we have a fundamental chord theorem called perpendicular bisector theorem, which states that a diameter drawn perpendicular to a chord bisects that chord. This means the diameter divides chord DE into two equal segments. Let's look at our measurements. We are given that line segment DB equals 8 units. This means line segment BE also equals 8 units. Now, the line segment BC equals 12 units. But this line segment AB is unknown, so we assume this as X. Now we apply the intersecting chords theorem. The theorem states that when two chords intersect inside a circle, the product of the line segments of one chord equals the product of the line segments of the other chord. So it means that the product of AB and BC equals the product of DB and BE. Let's substitute the values from the diagram, where AB is X, BC is 12, DB is 8, and BE is 8. So it becomes X times 12 equals 8 times 8. Now this side becomes 12X, and the right side becomes 64. Dividing both sides by 12, and we get X equals 5.3 units. So, segment AB equals 5.3 units. We know the diameter AC is the sum of both segments AB and BC. So, AC equals 5.3 plus 12. AC equals 17.3 units. Now, we can easily find the radius of this circle, as you know that the radius is half the diameter. So, divided the diameter into two parts, and it gives us 8.67 units. And that is the radius of the circle. I hope you enjoyed this.